When you have similar figures. When you had similar figures, this goes back again to last semester. Guys, come on. Guys. This goes back again to last semester. One of the last things that we talked about after, I think I actually did this right after Christmas before finals, because it wasn't a very difficult topic to get through. We talked about what were called similar figures. And with similar figures, what we did was that in order for two figures to be similar, all corresponding angles were congruent, and all corresponding sides were proportional. They were all proportional. And what we did was we used what was called a similarity statement. Okay? Real easy one to remember. If we did something if I said that, what's up here? A, B, C, D was similar, remember squiggly or tilde or an enye, I was about to say that too, not to be confused with enya. She'll sail away with you. At least you get that song. It's not funny because I have bad memories of Enya music. So basically, what this says is that angle A matches E, B, F, C, G, D, and H. All of those. Oh, she's early today. All of those things match up. The angles themselves match up.
Who is she?
It also means that the corresponding sides have the same ratio. Okay. So, in order for this to work through, then we were able to say AB is to EF, BC is to FG, CD. Bless you. We were able to do all of that. Nothing crazy, nothing too much about that. It was just straightforward ratios, and then we just utilized them, cross-multiplied, and solved kind of over and over and over again. Okay. Well, one of the things that we learned then was that if you had similar figures, the sides all had the same ratio, and then we also said that the perimeters also had same ratio. When we're talking about this common ratio, do you remember what we called that? We called it something fancy. Something. What do fish have?
Scales. And something with a factor. Scale factor.
Wow!
I said eyeball.
It's called scale factor. All right, so we had what was called scale factors, common scale factors. Okay. Well, what happens now today when we're talking about when we start getting into the perimeter and areas, we start looking at them in terms in 11.3, just like we had before, similar figures have the common scale factor. Similar figures have the common scale factor for their perimeters as well. And then what will happen with the areas, this is actually pretty simple. So we have ratios of sides. Was A to B. Ratio of the perimeters was A to B. This wasn't new. We've done this. The areas, the ratio of their areas then, what do you think? Try again.
Area.
Okay. So what happens then is that we're going to be able to take and work through, let me just skip ahead to this. We'll be able to work ahead to figuring out the ratio of their areas, okay? Because we can use the ratio of the areas to find missing side lengths. We can use the ratio of the areas to find the scale factor, just by knowing that the ratio of the areas is something squared over something squared. It's just the ratio of the sides. So let's go right to an example of triangles and work off of it from there. Excuse me. So what we have here is triangles that have the ratio are sides ABC and triangle DEF. And it says right away that they are similar. Remember, usually what we do is we go from left to right because we use our similarity statement. Let's move this here, put this up. So I have room. So what I would do, just to get in the habit again, is that it's AB is to DE, BC is to EF, AC is to DF. And all I'm doing there is just writing out that similarity statement. If you guys recall, whenever we did these similarity statements, the more that you wrote it out, the easier it became. Because the numbers just fell into place. Same thing, okay? It's gonna be the exact same thing. So, of those 6 parts, we know 2 of them. We know BC and we know EF. So what we do is, we know that it's going to be 8 over 12. And do we ever leave our fractions unsimplified? No. How do I simplify that? If I put that in my calculator, it'll do it for me right away.
2/3.
So you get 2/3. So here's the ratio of the sides, which means, what would be the perimeters then? I asked perimeters. Perimeters and sides have the exact same ratios. Okay? Actually, I should write it like this. Which means then the ratio of the areas would be 2 squared over 3 squared, otherwise known as 4/9. Now, what's nice about your calculators is that if you put it in a fraction, if I'm not mistaken, double check with mine, because I think mine will work with the fraction bar too. I think this works if you do this. Yes. If you square the fraction, it'll do it for you automatically and keep it simplified. Yes, sir. Yeah. Okay. Now, also what's nice about the calculator is that if you started with your 8/12ths, in the calculator here, if you type in 8 over 12 and hit enter, it automatically spits out 2/3 for you. It simplifies it. If you just hit squared, it'll give you 4/9. Okay? So it's nice that these calculators would do that nice little trick for you. Okay? So it's a little bit less work. Not too bad? Okay. Excuse me. Okay. So if we have okay, let's work through it. Well, what I'm asking you here is, if, like in part A, if the ratios of sides are 6 to 11, what's the ratio of the perimeter? Exactly. And then what will be the ratio of the areas? One. There you go. You're on, you're almost there. All right. So what you're looking at, it's a lot of times it is quite literally pressing a couple of buttons on your calculator, which kind of reminds me, you need to make sure you have a calculator at all times. I know, right? Go figure. There's only so many days left, and math is kind of important to know how to use a calculator. Okay. So on the first one, real easy. When you put through 6 to 11, if that's your sides, what's your what's your perimeters? 6 to 11. Areas, we just said. And I don't believe that would simplify for you, correct? Right. Because if it would, if you put it in the calculator, it would do it for you. It doesn't. It won't go 6 to 11. No, put 36 over 121. Because what you're thinking here is that means that 36 is divisible by 11.
Oh.
And 121 is divisible by 6, or doing something like that, okay? So not always will they simplify to one another because you're squaring it, okay? So you're going to get different ratios because the size changes, okay? Yeah. Now, if this is 20 over 36, when I throw that in my calculator, what is it, 4/9? Is that right? No, not 4/9, I'm sorry. 5/9. Thank you. I fake it pretty well. For what? The areas? Sides and perimeter will be the same because 20 over 36 simplifies to being 5/9. Well, they're giving you this to start with. They're making you simplify it. That's all. Yes, sir.
When you find the area, can you use both of those?
You always want to use a simplified one because I believe that if you do 20 over 36 and square it, won't it still spit out 2581? Yeah, it should. Yes, sir.
So why is the ratio for the sides for B, why is that 5/9 and not 20 over 36?
Because this can be simplified.
Okay.
They're just telling you right off the bat, sometimes they're going to give you a form that it can be simplified, just like that 8/12. We simplify it, okay? We do the same deal. No matter what, all you're doing is when you're dealing with perimeters and sides, you're simplifying a fraction.
Okay.
If it wasn't simplifiable, you just leave it how it was. Like if it was 23/36, you just leave it 23/36.
Okay.
And then this one was 25/81.
Yes.
And it does that, okay? Now, what we're going to wind up being able to use this stuff for is we're going to be able to figure out, guys, we're going to be able to figure out missing areas, okay? So, I'm going to be able to figure out what the area of the blue triangle is by using ratios. So they're giving you two side lengths, and they're giving you one of the ratios. Excuse me. So one of the triangles has a side length of 2, the other one has a side length of 6. So how I start this problem out is that I know that my ratios of the sides is 2 to 6, which gives me what as a scale factor? 1/3, very good. So there's my scale factor of the sides. To that, what do I do to get the ratio of the areas? I square this. When I square 1/3, remember that means it's 1 squared and 3 squared. Or throw the calculator, you do 1/3 and you hit the square button and it should spit out 1/9. Now this is the ratio of the areas. Now you have to remember which one was the numerator. Well, the numerator was my red. My denominator is the blue. I went from sides, red to blue, which means they're giving me the area of the red, and I need to find the area of the blue. What's x? Very good. Remember, we went from red to blue, and we just have to keep it straight. Just like how we were doing that before. As long as you keep your correspondence correct in the direction that you're looking, it's always going to work itself out. And it's not a lot of hard math, if you will. Pretty straightforward, I'd like to think. Okay? It's pretty straightforward. Okay? Shall we do another one? All right. Let me move this to the other one. Oops. Okay, we have two figures. In the directions they tell us that they are similar. We don't have to worry about writing out that full-on similarity statement or whatnot. So the first thing we're going to figure out is the ratio of our sides. Now, I'm reading it going from from left to right normally. So I'll say that my sides would be 15 to 20. Just reading from left to right. If you read right to left, does it change anything? It just flips it. You still theoretically get the same answer if you do it right. Yeah, you still get the same thing. Now, 15 over 20 then, you automatically simplify it. When you simplify it, like you're saying, you get 3/4. There's your scale factor. Now, taking that 3/4, what do I do to get the area ratio? Square it. So if I square 3/4, I get 9/16 as my area. I need to find the red, which is in my numerator, and I know my, oh, sorry, I looked at the wrong number. This is 240 down here. I know that one, which means I cross multiply and solve. So when I cross multiply that out, we're going to get 16x equals 0, 6, 3, 2160. Yep. And then divide out. Bless you.
Thank you.
1, 5 left over. Huh?
135.
Okay. It's the same thing because what I'm setting up is the surefire always going to work. You're just isolating that by multiplying by 240.
Yeah.
You're saving yourself that divide back to 16. It's not a big deal. All right, it's not what you're doing is fine. Okay. And then that gives me my first area. So what this looks like today, it's a lot of, hey, you did this before with ratios and stuff. Let's just add one part to it by squaring it. Hey, just a little premonition. Now, if sides are linear, perimeters are linear, areas are squared, volumes are cubed, what do you think the ratios of volumes are going to be? And we'll get to that in a couple weeks. Okay? No, not yet. Bless you. All right. So these are the ratios of the areas. Now, when you have ratios written with the colons. Do you remember what goes in the numerator? The first number. Now, if these are ratios of, bless you, if these are ratios of areas, and then it's saying 16 to 121, and I want to figure out what the ratios of the sides are, or the ratios of the perimeters, what do I do to that to get to it? Square root, good. Now, do you guys know how to take a square root of a fraction in the calculator?
Yes.
You press the square root button and then make the fraction. So you get and you get 4 over 11 then when you press the buttons. Okay. Yeah. All right, so if your areas are squared, to get to the sides, you just take the square root. Hey, just so you remember this, if your areas are, or your volumes are cubed, how do you work your way back to the sides? You cube root. And then from that cube root, after you do that, then you square it to get to the areas. There's just pressing buttons. On the calculator, there's a button here. See where it has the caret? See where the caret button is? If you hit 3-second caret, it turns into a cube root. And then type in 8, and then you get 2.
What's the caret?
It's mine's different. It's a. There's a button that looks kind of like this. It's got an X root something in it. It's right. It's in the second part where you have the little superscript button. So that's how you do it. We're not to that yet, so. All right, let's do this. And the idea of working backwards from areas to finding a side length. I'd like to figure out what that side length is. So we have a similarity statement. We have given areas. And I want to figure out sides. So let's take a second and draw it and work our way through it and see how we do. Actually, you know what? We'll hold off on this one because this one takes a little bit longer. We'll stop here. Now I realize what time it is. Yeah, it's not too much here. I'm not going to go too crazy right off the bat. This one takes a good day or so to get through.
He's not my son. He's my son.
Alright, let's see you do those.
Do those, please.
I have a question.
Yes, ma'am.
Oh, yeah, I see.
When you click more details, everything pops up. On the calendar. All the assignments that they posted on the calendar. So any worksheets and all that are always on the calendar. Do those. We'll talk about working through the rest of it tomorrow.